MuxSelector is special type of combination of multiplexer and selector. So let's try it, for example, multiplexer selector for real data type. All of them are same for boolean and unsigned integer. There is just a difference in using of data type. So this multiplexer selector is basically a configurable selector. I will explain it immediately on different case. For example, if there is a channel on input k is 0, so we say that we select channel 0, but it's not defined here because there is only channel 9, 3 and 14. In case that this channel is not defined, so it is in else group. So in this case it's selected else group, which is 20.3. So the input is not selected, therefore this input selected output is false, and the connected value is else, which is 20.3. In case that I will change it to number 2, so it's still the same value. In case that I change the channel, for example, to number 9, which is defined, so it immediately changed the value to 18.1 and input is selected. The same for number 3 and number 14. We can write directly the value here on the block, or we can connect it. It's really useful because we can easily extend this block. In case that we would like to extend this block because it has only, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 position, so we can chain this block to get with that. So let's take 1, let's define value 1, for example, like that, and let's extend it to 9, 11, 13, 15, whatever. So I will connect this value with else, and with OR block from, for example, original library, from binary we can connect OR functionality, and it's selected in this block or it's selected in this block. And else value is, for example, 11.0. Let's try it like that. And let's use force marker from extended library, force marker for testing, like that, and we need to connect common input for both of them, like that, like that. Okay, and we can chain it. We could create, for example, the same for 3 blocks as well. Let's make it bigger to have it more interesting. So the last value comes from the last block. So else it must be connected, and we need to extend it if it's selected. Great. And the result is in this position. So let's try it. Maybe we should just change this to have different values, because it will find the block. So let's change it to 17, 19, 50, 60. Like that, and values are okay, I think. So let's try it. So in case that we have input 1, which is defined, and or 0. Let's start with 0, which is not defined, and let's start it. So 0 is for else channel, which is 11. In case it's 1, it select the value from the first block, which is number 5. 2, not selected, it's else. 3, 10, 4, not selected, 5, 15, 6, not selected, 7, 20, 8, not selected, value 11, 9, second block, selected, value 5, 10, else value, which goes from the last position. 41, it's not defined. 11 from the second block, 13 from the second block, 15 from the second block, value 16, it's else value, it's not defined, the channel is not defined. 17 from the third block, 19 from the third block, channel 50 or 49, not defined, value 50, channel 50 or input 50, it's value 15, and input 60, which is 20. Yeah, and that's it. So with this block, it's like a puzzle. We can easily extend this block with like a chain in this way, which is really great and wonderful. I really like it, and we can work with that, for example, with state machine logic for chillers or heat pumps. It's really useful in that case. Or we can find many other possibilities how to use this block, and we have the same for different data types. So we have the same for Boolean value on input, for real value, for unsigned integer as well. So the channel is unsigned integer, then also the value is unsigned integer, which is connected to the output. We can try it here on this Boolean mux selector block. So if it's 11, so it's not selected, so value is else. If it's value 12, so the value is true and the output is selected, and if the value is 56 or 55, so it's not selected, and 56 it's selected, which is true, and it's selected is also true. Yeah, and that's really powerful.